This class is on kinematics, and the questions we are doing are on paper 1. On a particular railway, a train driver applies the brakes. On a particular railway, a train driver applies the brake of the train at a yellow signal, a distance of 1 kilometer from a red signal, where the train stops. Stops means velocity. The maximum deceleration of the train is 0.2. He says that uniform deceleration is there. So it means that you can apply equations of motion. You can apply equation of motion at the yellow signal. So yellow signal, at a yellow signal. So when the driver applies the brake, so let's say the speed is u meter per second. So I can apply 2as is equal to v square minus u square. But I don't have, distance is 1 kilometer. I need to find this u.
It's B, sir.
Is it coming 40 after underrooting? Yes, sir. Can you hear me?
Yes, sir.
After taking the root sign.
Yeah. It's not coming 40, sir. It's coming as B.
B.
Yeah.
And what's coming inside the under root? Is it coming 400?
Yes, sir.
A person traveling on a motorway a total distance of 200 kilometers travels the first 90 kilometers at an average speed of 80, which average speed must be obtained for the rest of the journey if the person is to reach the destination in a total time of 2 hours 0 minutes. So we have a full journey. We have a full journey, like we consider this as our full journey, and it's a distance of a total distance of 200 kilometers. The first 90 at an average speed of 80. So first 90 at an average speed of 80 kilometers per hour. Which average speed must you obtain for the rest of the journey? For the rest of the journey will be 110 kilometers. And he says the total time is 2 hours. The total time is 2 hours. So we have the picture. We should first see that the formula for average speed is total distance upon total time. He says what should be obtained for the rest of the journey. So we have the distance. We should find the time already consumed in the 90 kilometer journey and then subtract it from the total time of 2 hours. So first we find velocity is equal to distance upon time. So time is equal to distance upon velocity. Acha. Okay. Saad is saying answer is D. Other people should also contribute. Saad has suggested an answer D. I'm finding the time for the first part. 200 kilometer is the distance. Sorry, 90 is the distance. Speed is 80. This is the initial time. And if I subtract it, so find the remaining time, and then we can use the average speed again. D. Two people are saying the answer is coming D. I'm getting 110 upon 7 upon 8. This is the working of the question. And then he says an object in air is thrown upward and towards the left. Is thrown upward and towards the left. It looks like a projectile case, which diagram shows the forces acting on the body when it is at the highest point, because he says upward, and he says towards the left. So it seems like a projectile question. So which diagram show? Because if it is going on a tilt, so which diagram shows gravity is definitely acting downward? Let's say I throw it like this. So at any point when it reaches the highest point, this is the highest point. At the highest point, the object will be facing one force downward, which is the weight. But what other force? So answer is A or one more force? D. One answer is suggested to be D, but I did, because C can't be the case. B is wrong. Why not A? Because if it is going to the right, there must be a force on the right. It is going to the right. So it must be having a force to the right. The mass acceleration, the mass accelerates uniformly when the resultant force acting on it is. So he says mass accelerates uniformly when the resultant force acting on it is zero. If resultant force is zero, then acceleration would be zero. This is possible that it is constant. It's a theory question. It's simple. Note the previous question. He says he has thrown something upward. Thrown something upward and to the left. Thrown something upward and towards the left. Acha, I have made it to the right. That's why, because I didn't read the question. This is the mistake I did. That's why some people are having a confusion. Some people are having a genuine confusion because object has been thrown to the left. And when it reaches the maximum position, it is experiencing one force downward and one force backward. This is the case. And the object is moving in this direction. At the highest point, the object will receive air resistance. Object, when it is moving in a projectile, air resistance is always there. Achha, a mass accelerates uniformly when the resultant force acting on it, resultant force has a formula, resultant force is equal to ma. So it can't be zero. If resultant force is zero, acceleration will be zero. It's constant. Resultant force and acceleration are directly proportional. So I should take the option of directly proportional. Achha, C increases uniformly with respect to time, but he says uniform. If he wants acceleration to be uniform, if acceleration is uniform, the force should also be uniform. 35. Suggest your answer. One answer is C. Definitely it's not zero. It can't be zero. Proportional to the displacement. That is not possible. Acceleration is not proportional, or resultant force is not proportional to displacement. So that is also wrong. Option is B and C. ठीक है. So better answer is B. Why? Because it is constant but not zero. So acceleration and resultant force are constant. If you want acceleration to be constant, resultant force is also constant. C means acceleration. C means the resultant force increases. C means resultant force increases, but resultant force should not increase because otherwise acceleration will also increase. A tennis ball is thrown horizontally in air. It looks like again a projectile question horizontally in air from the top of a building. If the effect of air resistance is not negligible, what happens to the horizontal and vertical components of the ball velocity? So suppose that this is a building and this is the ball, and we throw it like this, it goes down. This is the motion. Now, this is how projectile is launched. Air resistance is present. What is the effect? If air resistance is present, it will oppose the horizontal motion. It will oppose the horizontal motion and it will oppose the vertical motion. It will oppose horizontal and vertical both motion. So now horizontal component can't be constant. It is constant when air resistance is not considered. So horizontal component decreases to zero. That is fine. But what about the vertical component? If it's a tennis ball, can it reach terminal velocity? If it is a tennis ball, it can reach terminal velocity. It's a tennis ball. He says the increases to maximum value. Increases at a constant rate. Look, increases at a constant rate means constant acceleration. Increases to a maximum means terminal velocity. So in the given condition, it looks like that the ball will reach terminal velocity because constant acceleration is not possible. Actually, acceleration is constant. Actually, acceleration is constant when there is no air resistance. Okay, now you try this question. You have to try this question. I'm just coming. I have to say namaz. If any one of you has to say namaz, they can also. I'm just coming in few minutes and we can start from the same position. A radio-controlled toy car travels along a straight line for a time of 15 seconds. Velocity becomes negative. It means it looks like a U-turn. Average velocity average velocity is resultant displacement upon total time. This total time is 15. But how I find the resultant displacement? Let me find the area above x-axis, it will be 3 into 10, 30. It's a positive velocity, it's a negative velocity. It means it's a case of U-turn. Okay. One more answer is here. Now I find the area here. It is 6. This is the area. Now, how I find the resultant displacement? Remember the rule: area above x-axis minus area below x-axis. To find the resultant displacement and tell me how much resultant displacement will come up. How come 4? I don't know how people are getting 4, but look, the resultant displacement 30 meter above x-axis, 30 meter below x-axis. The resultant displacement is 0. When displacement is 0, it will be 0. So check it again. Let me check also, because I am getting a subtraction 0. You can say like that, no? But the point is that it is a reverse direction area. Displacement, right? You got the right point. In order to find the resultant displacement, you have to subtract the area above x-axis with area below x-axis. It's a U-turn case, actually. Actually, the diagram can be translated in this way, that the object travels 30 meter forward, it returned and travel 30 meter backward. An object is thrown with velocity 5.2 and the object is thrown vertically upward on the moon. The acceleration due to the gravity on the moon is 1.6. It is the value of g there. What is the time taken for the object to return to its starting point? So let's do one thing. Find the time to reach the maximum height, and then we double it, because when as the moon is the case, so there is no air resistance. So time to reach the maximum height will be the time to reach ground back.
Okay, sir.
This is the journey. I am taking only upward journey. So A will be equal to minus 1.62. I have made the data for the upward journey. And now I want you people to find the time.
So what formula do we use?
Any equation of motion like S is equal to ut plus half at square, or 2as, or v is equal to u plus at, or 2as is equal to, we do not know the height, but the final velocity is 0. So we have to select a formula. We have u, v, and a. Right, you can use that. Definitely, Sakina, you're right. I'm using this formula. It's also the same form. Let me help me to get the value of time. An experiment is performed to measure the acceleration of free fall. A body falls between two fixed points. 4 measurements shown below are taken. Which measurement is not required for the calculation of G? So if something is falling and we mark 2 positions like this, and something is falling, this is position 1, this is position 2. And we want to find the acceleration of free fall between two fixed points. The 4 measurements shown in the below are taken. Which measure the distance fallen by the body, the initial velocity of the body, mass of the body, the time taken for the body to fall, keeping in mind the equations of motion, and we just have calculated some work above, which value is not relevant. I mean, which is not required in the calculation of G. Mass. The graph shows how the acceleration of an object moving in a straight line varies with time. This is acceleration versus time graph. And he wants to convert it into velocity time graph. So what's happening in the start. There are two patches initially. If I mark here, initially acceleration increases to get maximum. Here, acceleration is maximum. Here, acceleration is decreasing. And here, acceleration is increasing. So initially, acceleration increases, become maximum, and then acceleration becomes zero at the highest of the velocity of the object over the same time interval. Remember, when acceleration is maximum, velocity is zero. When acceleration is maximum, velocity should be zero. So try this one. B. B is a matching. Acceleration and velocity cannot have a matching graph because acceleration and velocity are not compatible quantities. Velocity becomes acceleration. So velocity and acceleration cannot have a matching graph. Similarly, D has an issue. I'm waiting for other people. I have an option of C, but B is wrong because B means acceleration and C. Uh, B is wrong because acceleration and velocity cannot have similar sketch. D. Okay, one option is now A. I'm also going to reject D because D shows one pattern. D means velocity is increasing at an increasing rate. Velocity is increasing at an increasing rate. So we have an option now. We have two. We have an option C, B, A, and C. The object is moving in a straight line. There is no U-turn. So the object does not stop anywhere. Velocity is not zero at any point, which I thought initially that velocity will become zero, but it's not making any U-turn. So we have a suggestion now about A. A means that initially, if I put a mark here and I put a mark here, so one is increasing acceleration and one is decreasing acceleration. And this is matching with our sketch. So after complete working for every part, we got as our answer A. Why rejecting C? C shows velocity becomes zero and then velocity becomes zero again, which is not the case here. Velocity is not becoming zero twice. In a CRO, an electron is accelerated uniformly in a straight line from a speed of this to this over a distance of 10 millimeters. So this is U, this is V, and this is D. What is the acceleration? Ten millimeter. Solve this question. When he says acceleration is uniform, when he says uniform acceleration, then the best option is equation of motion. Now try this option A for acceleration. Find this. D is the right answer. Good. So majority people are saying D. If anyone has to give a feedback, that should also be given. So we stop here and we will continue this inshallah in our next class.
Okay, sir.
Allah
Assalamu alaikum. Assalamu alaikum.